Okay guys, I'm going to start something a little bit new, see how this works. Try recording a copy of the PDF that you guys are doing later today or tomorrow. So the warm-up starts off with finding the unknown angle A. So this first one means we are going to find angle A by doing the inverse tan, opposite over adjacent. And when you enter that on your calculator, it will give you 39 degrees. This second one is based on a non-right triangle, so here's B, which is 28, and little b's opposite. If this were A, then this would be 15, and we're going to use the law signs. So the sine of 28 is to 10, as the sine of your unknown angle A is to 15, and when you cross multiply, you would get that the sine of A equals 0.704, and then you would do an inverse sine so that you would find A is around 45 degrees when you round off. And then this next one, we have all three sides. So we have 8, 8, and 6. I'm going to call this one A. So when you have side, 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 you have to do the log cosine. So it's going to look like this. 8 squared equals 8 squared plus 6 squared plus, oops, sorry, let's erase that. That is going to be a minus 2 times 8 times 6 times the cosine of angle A. And so then we're going to go through and solve for angle. We'll go ahead and solve for cosine of A here. So the way this will look, so we have 64 minus 64, these will go away. We'll then get minus 36, and then we will divide by the quantity negative 2 times 8 times 6, and then when we do the inverse cosine of that, we find that A will be about 68 degrees. Okay, now what this whole presentation is about is inverse trig, looking at your inverse function. So something you may not realize is that we call these inverse trig, and you've seen this, so this should look familiar, but some of you might even have this. I've seen it on some of your calculators. They basically are two ways of saying the same thing. The reason why we do that is a lot of times when you're talking about inverse trig, you're talking about the length of an arc and the angle that would give you that arc. So they use the arctan, arc cosine, arc sine. They mean exactly the same as what we have seen as the inverse sine. So I just want you to get comfortable with that terminology. Now this is going to be completely new. We haven't really looked at what the graphs of these functions look like. So I'm going to just do this in a very cursory way. Something you need to understand is that when you take the inverse sine of something, the calculator has to give you a specific angle because the answer to these is an angle. You're taking the inverse sine of a ratio. Well, sine, let's start with sine. Sine is positive here because it's the y values. Sine is positive here, it's negative here, and it's negative here. Well, if I'm taking the inverse sine of, say, a negative ratio, which quadrant should the calculator give me my answer? So to solve this issue, we have what are called the range of the values. It also has to do with being a function, but that would require you knowing something about the graph. And that's, right now we're just going to focus on that the calculator has to give you one quadrant, because it can't give you both quadrants which would satisfy the answer. So for sine, you're going to find that it will give you a graph or an answer in these two quadrants, from negative pi over 2 to pi over 2. So for instance, if I were to ask you what is the inverse sine of negative 1/2, the answer would be negative 30 degrees. It would give me an answer that is down here, where your sine is negative. Okay? So we have that the inverse sine will come from negative pi over 2 to pi over 2. So this one is for your inverse sine graph. Your inverse cosine graph, well, cosine is the x values. X values are positive here, negative here, negative here. So what happens with that? Well, it's not going to give you between negative pi over 2 and pi over 2 because those will both be positive. It needs to give you one quadrant positive, one quadrant negative. So what it does is it chooses between 0 and pi. So if I asked you what is the inverse cosine of, let's stick with 1/2, in this case it's going to be your 60-degree angle, which is pi over 3, here in the first quadrant. If I wanted a negative 1/2, it would be over here at 2 pi over 3. Okay. I don't want to get rid of everything, so let's just get rid of this. So then let's go ahead and fill in the cosine down here. So cosine will happen between 0 and pi. And lastly, we have your inverse tan. The inverse tan, you have to remember, tangent is not defined at negative pi, at pi over 2 and pi over 2. So because tangent is positive here, and it is positive here, and negative here, and negative here, it's going to give me answers in these two quadrants, but because it's not defined at the pi over 2, it's still in that interval, but notice that in the inequality we don't include the equal to sign. So your inverse tan is going to be from negative pi over 2 to pi over 2, just like sine, but not inclusively. Okay, so now let's actually go through and try and find some of these values. And maybe it will help to draw your triangle first. So let's just kind of keep as a reference down here at the bottom a 30, 60, 90. So you have 1, you have 2, you have rad 3, and a 45, 45. So I do expect you guys just to be able to put that down. So the inverse sine of 1/2. So we look at the 1/2 opposite. That means this goes with a 30-degree or pi over 6. I want you to learn your radians, so I'm going to do everything in radians. If it's negative, it will be in the fourth quadrant or the pre-first quadrant, so we'll write negative pi over 6. If it's inverse sine rad 3 over 2, that goes with a 60-degree angle, so we're going to write this as pi over 3. And inverse sine rad 2 over 2, which remember is the same thing as 1 over rad 2, that's a 45, but negative, so we go negative pi over 4. Now for the cosine, we're going to do cosine of 1/2 adjacent over hypotenuse. That goes with a 60-degree, so this will be pi over 3. Inverse cosine negative, so this one now has to go to the second quadrant, so that's going to be 2 pi over 3. Inverse cosine rad 3 over 2, that goes with the adjacent over hypotenuse, goes with a 30-degree, so we're going to write that down as pi over 6. Negative rad 2 over 2 has to be in the second quadrant since it's negative, so that one is going to be 3 pi over 4, or 135 degrees. And then we are going to lastly do our inverse tan. So negative rad 3, so that's like rad 3 over 1. So the opposite over adjacent goes with a 60-degree, but it's negative. So this will be a negative pi over 3. Inverse tan 1 goes with a 45, opposite and adjacent being the same. So that's just straight pi over 4 because it's positive. Inverse tan rad 3 over 3, remember that's the same thing as 1 over rad 3, so opposite over adjacent, 1 over rad 3. That is going to go with a 30-degree, so that will be pi over 6. And lastly, we have the negative 1, which gives me negative pi over 4. Okay, so now we get into, so that was when you had to deal with just finding an inverse trig and worrying about which quadrant you can get the appropriate answer in. And that's in order to keep them a function and to deal with the fact that your calculator is only going to give you one answer for the positive and one answer for the negative. So it chooses very specific quadrants, which we call then the range of those functions. Now this gets a little bit easier. So let's go back. When you were first learning how to find the sine of an angle, and you didn't know what the angle was, but you knew the ratio, what did we do? We actually took the inverse sine of both sides, and an inverse function acts just like when you take, say, x times 1 over x, and they cancel each other out. These two canceled each other out, leaving me with a, so a equaled the inverse sine of 1/2. Well, it's really nice when you're taking the inverse of itself because it will operate the same way. So over here, if I take sine of the inverse sine rad 3 over 2, they cancel each other out and the answer is just rad 3 over 2. If I take the cosine of the inverse cosine of negative 1/2, the answer will be negative 1/2. And here the tangent of the inverse tan, your answer will be rad 3 over 3. So these ones are pretty friendly. Now we don't always take the inverse of the same function, but as I'm going through this, I want to remind you, we always take the sine of an angle and the answer is a ratio. When you do the inverse trig, you're taking the inverse trig of a ratio and the answer is an angle. So let's see what happens when you have to do that and they aren't inverses of each other. What you want to do then is draw a triangle. Okay, so to draw the triangle, we are going to first pick a color. So we're going to draw a triangle. So remember that this is the tangent, this right here represents an angle. And the ratio that goes with that angle. So the inverse sine is so here's the angle. And we have inverse sine, so that's the opposite over the hypotenuse, so we know that'll be a 1. And so we're trying to find the tangent of this angle. So tangent, and again our answer should be a ratio, so the tangent is going to be the opposite over the adjacent. So the next one, let's do that in a different color. So we have the cosine of an angle, so what does that angle go within the triangle? Well, inverse tan rad 3 over 3, remember that's the same thing as 1 over rad 3 rationalized. So we have the opposite over the adjacent, which means the hypotenuse will be 2, and the cosine of that is the adjacent over the hypotenuse. And then let's try, let's do cotangent, inverse sine 4/5. Now this one's not one of your special triangles, but it doesn't matter. Notice we haven't actually identified any particular angles. We're just using the fact that we know the ratios that go with these. So inverse sine is the opposite over the hypotenuse. The adjacent will be 3. Cotangent is the reciprocal of your tangent, so that one will be the adjacent over the opposite. And then next we have the secant of the cosine, inverse cosine. So inverse cosine, that triangle, is going to be the adjacent over the hypotenuse, which means the opposite is 15. It's an 8, 15, 17. But I didn't even really need to do that because look at what happens. Remember that secant and cosine are reciprocal functions. So the secant of that triangle will just be the reciprocal of this hypotenuse over adjacent. So if you see that you have the reciprocal functions, you can just take the reciprocal of that ratio. Kind of makes sense. Okay, I know this was a lot, but in summary, you are going to need to learn what are the, you're going to need to learn what are the, it's having a trouble writing here, what are the principal values in the range that goes with those principal values. So remember, inverse sine, negative pi over 2 to pi over 2, and inverse cosine from 0 to pi. So here your negatives, your positives, your negatives, and then inverse tan is also from negative pi over 2 to pi over 2. Realize that all three of them, anything that's positive, it's always coming from the first quadrant. The only issue is when they are negative, okay? Then next we had the trig and the inverse trig. They cancel each other out. And lastly was when you're doing the trig and the inverse trig, but not of the same trig, then you just want to make sure that you can draw a triangle and label the sides. Okay?